Welcome guys in this video session. So in this video we will discuss about equalizers. So equalizers in wireless communication system, basically equalizers that are used in the receivers. So how the equalizer works in the receiver. So all the basic things of equalizer that we will discuss in this videos. So guys, please watch the full video. So one more thing I want to tell you, if you have not subscribed my channel, then please subscribe the channel and like the videos. So let's start the video here. Basically, firstly we need to know what are the equalizers. Basically, equalizer is nothing but it is a simple inverse filter. The equalizer that works in the receiver like a filter and helps to minimize the ISI, inter-symbol interference in wireless channel. So here simply equalizer, that is here the inter-symbol interference that is caused due to the multipaths and distortion of the signal. So this inter-symbol interference will be minimized when we use these equalizers. So equalizer is used to combat the inter-symbol interference and helps to reduce the bit error rate, basically. So how the bit error rate is reduced? So guys, what is bit error rate? Firstly, so when we transmit the data from transmitter in a bits, so when we receive the data from channel at a receiver in the bits, so some bits may be interchanged or maybe reduced or maybe increased from random bits. So these random bits, the original data that we have transmitted, that is in maybe in these random bits or not. So some bits may be interchanged and maybe have an error of the bits. So basically that is called the bit error rate. So this bit error rate will be reduced with the use of equalizers, and ISI is basically due to the major obstacles in high speed transmission in the wireless channel. So equalizer that describe the signal processing and helps to minimize the inter-symbol interference. So the mobile channel, that is basically a random in nature, and it is the channel that have a time varying characteristics, that is vary with time, and equalizer tracks the time varying characteristics basically of channel. And in the adaptive equalizers, basically adaptive equalizers are the advanced equalizers. So in these equalizers have used some recursive algorithms that are very helpful for tracking the time varying characteristics of channel. And some general modes of the equalizers that are tracking and training. Tracking means it tracks the channel or a signal from the channel and send the or receive the some training sequences. And training sequences are the first basically a sequence that is firstly received from the receiver, and with the help of this training sequences the signal is received and the user signal is received at the receiver. So here, as in the block diagram, or we can understand this equalizer with diagrammatically. Here this is a transmitter and this is a receiver, and between there is a channel. So from when the transmitter is transmit their signal from transmitter to the channel, and firstly it transmit the training sequences. Training sequences may be a fixed or pseudo random binary signal. So this signal is transmitted, and then due to this signal or training sequences, the user data is sent to the channel. And at the receiver side, when this data is received from the receiver, so in the receiver there is a equalizer is used in the receiver. Basically equalizer is the part of receiver. So in the equalizer that have used recursive algorithms that helps to estimate the filter coefficient of channel and this algorithm will help and compensate the effect of distortion basically, and it do the proper filtering of the worthy channel condition basically. The signal that we have getting from the channel that have worthy condition, so it basically do the proper filtering of that particular signal that is getting from channel. So let's move to the next section, next slide. Here when the filtering is finished, then the filtering coefficient or the value of this filtering coefficient or signal that is close to the optimum value of the signal that is transmitted from the transmitter and received at the reception of user data basically. The user data that is transmitted from the transmitter, this value, this filter value was reaches close to the that transmitted values basically, because of this filtering. And here the equalizers requires the periodic retraining to effectively cancel the intersymbol interference. So equalizer needs a periodic retraining sequences that are maybe periodic, repeat after some instant. So equalizer is implemented at the baseband or intermediate frequency, we can say at the receiver. So equalizer usually simulates the channel response and demodulations, etc., these type of things on the baseband. And time division multiple XX technique is used in the equalizers, that is well suited for the equalizers. And in this TDMA technique, basically on the same pilot sequences, or we can say training sequences, this TDMA technique transmit the different data on the different blocks, because in the TDMA technique that have a different time slots that are transmitted the different data on the same frequency basically. So the training sequence is received at the beginning of the blocks. Training is the basically training sequences are the pilot sequences, we can say, that are firstly received at the beginning of the receiver. Firstly receive these training sequences, and then each time slot in the each time slot new data is received at the receiver on the same training sequences. So here the some derivation components are there. X of t, that is the original information signal that is transmitted from the transmitter. F of t is the combined impulse response, or basically combined baseband impulse response. So y of t is the equation or signal that is firstly received at the receiver, where have the original signal is convolution, or the convolution of this original transmitted signal and complex baseband impulse response, these two convolution of these two signal. Here this is the complex based, so here the conjugate is there, there may be imaginary and real values. So here x of t is convolution with this f conjugate of t plus nb of t, that is noise signal that is added with this signal. So this signal is firstly received at the receiver, and then here this d cap of t, this is the estimated output of the equalizer basically. This is the estimated output. And HEQ is the complex baseband impulse response, only complex baseband impulse response, and f of t is the combined complex baseband impulse response. So this is difference between them. So here this is the estimated output of this equalizer, that is x of t convolution with this conjugate f of t, and that is multiplied with this baseband impulse response and plus noise is added. So here basically what is in this equation, here in this y equation this HEQ or complex baseband impulse response is multiplied with this y of t equation. So here this is the estimated output of this equalizer. So if we replace this impulse responses, both the combined impulse response and baseband impulse response. So if we replace these with g of t here, g of t, then the equation, this equation is replaced with here x of t, that is multiplied with g of t here, plus remaining same noise is multiplied with heq of t basically. So this equation remaining same, only here replace the g of t from with this f conjugate of t, that is multiplied with heq of t. So here this is the estimated equation for the equalizer. So let's move to the next section, next slide. So here as you can see in this, here this is a block diagram of equalizer. Here this is the x of t, that is the original signal, x of t signal, message signal basically, that is modulated that is modulated with the help of modulator, and then with the help of transmitter it is transmitted to the channel, and at the receiver firstly received this signal, and here the intermediate frequency and matched filter is there. So firstly the training sequences may be received there, and the y of t equation is received here, and the noise is also added, that is recognized and may be reduced with the help of match filter, and here this is the plus sign is there where noise is added, and at the equalizer, before the equalizer the y of t equation is received. Which y of equation? That is this y of this equation, this y of t equation is received at the receiver here at the equalizer, and the work of equalizer is to basically filter that particular received signal and reduce the bit error rate. So basically here the equalizer this equation or this signal is when received the equalizer, then it will filter that particular signal, and also the work of this equalizer, it estimate the channels with the help of that training sequences. It estimate the channel coefficient and estimate the data of the user, and here this is the decision maker section. So in the decision maker section here, if any of the error in this signal, so or in the data, that is feedbacked with the help of this, and here this is the expected values will be here addition or subtraction of this data or bits, and then this d cap of t, this behaves like a estimated output of this equalizer. So this will estimate the output, each output when the output is goes from equalizer to this decision maker, and here at the reconstructed data, this is d of t, this is basically the original output of the equalizer. If there is any error, that is feedback with this e of t equation here to the equalizer, and then multiplied with the equalizer, and then again this process is continue, go to the decision maker and go to the data to the output, reconstructed data or message data. So we want at this stage, what we want here, that is x of t that we have transmitted from this transmitter. So we want this data here. So this is the basically work of this equalizer. So here below, the g of t is the combined impulse response of the system, HEQ is the complex baseband impulse response. So this is the HEQ. How we can find this HEQ? So here the summation, or we find out the expected value of this with n time. So n are the number of this sequences, transmitted sequences, or we can say, so here C of n, that is the complex filter coefficient, that is we have estimated from the equalizer. So here this complex filter coefficient is delta time shifted, or the impulse of this complex filter coefficient is shifted with n time nt, t minus nt, here n time is shifted, this the impulse of this complex filter coefficient is shifted n time. So we get the this complex baseband impulse response. So what we want here, we want at the output is the input signal that we have transmitted from the transmitter. So we want that particular input at the output. So here to force that estimated output of the equalizer to the x of t or original output that we will get at the output of the equalizer, that is here this is simply the main goal of the equalizer is basically this is the impulse response or combined impulse response g of t, that is the conjugate value of this combined f of t, f conjugate of t, that is the combined impulse response, and heq of t, that is the complex baseband impulse response. So the convolution of these two, that is equal to the delta of t. Delta of t means this is the impulse response of this equalizer basically. So the main goal of the equalizer is to satisfy this equation. Basically in the output of this equalizer we want only the original or massive signal at the 0th position of the output, and remaining other values that may be 0, that we want 0. So we want only impulse function like the output signal. So if we want to convert this signal time domain to frequency domain, then we need to take the Fourier transform of this impulse, and then we get the signal in the frequency domain. So here the equalizer is basically here the definition of the equalizer, if we need to know, then basically inverse, it behaves like an inverse filter of the channel, and it do the inverse filtering of the channel, and it enhance the amplitude of this signal and attenuate the higher or strong frequencies of this channel signal. So that's all for this video, guys. If you have any query regarding this video, then please write in the comment section. So thank you, guys.